data collection and logging. Data is the foundation of every project. Now, I know screen design is the funnest part and you are excited to jump in, but it's really important to think about tag structure and data collection before you finalize your screen design. Keep in mind that reusability is the key to good screen design. A consistent and efficient tag structure is crucial to both screen design and data collection and logging. The first mistake we'll look at is inconsistent tag structure. Remember, consistency is crucial for reusability. Inconsistent tag structure slows development time and prevents you from using templates or reusable views. I see this most often when someone has built a screen for one device, then they realize, well, I need a screen for a similar device, but maybe with an additional set point. It's really easy to just start a new tag folder, add the tags, set the tag addresses directly, and then you can just copy paste a new view or window and set a few tag addresses. But this is not scalable and it's not maintainable. Another common mistake is to drag in all the tags from the PLC. This allows the PLC to dictate the tag structure. Each PLC could have a different tag structure, leading to inconsistencies. Excessive network traffic could be created by pulling unnecessary tags. Consistency leads to reusability. An inconsistent tag structure will increase development time and be impossible to maintain. The solution is user-defined types. These UDTs ensure a consistent structure. Reusable views or templates can easily be built from a UDT. Tag addresses can be parameterized, and multiple UDT instances can be created with just a few clicks. Modifications to a structure on a UDT can be made right on the definition. The changes will apply to all instances automatically. No more repetitive copy-paste. The next mistake we'll look at is improper polling frequencies. One mistake we see often is using the default tag group for all tags. The default polling rate is once per second. This means PLC tags poll once per second, expressions are recalculated every second, and query tags are hitting the database for data that may not have changed. Polling too often can slow down your system and waste server space. Now, not polling enough runs the risk of not collecting important data and therefore misrepresenting the efficiency of operations. It's important to understand the scope of your project early on to determine which information needs to be gathered and how frequently. The solution is tag groups. Let's talk real quick about what are tag groups. The name tag groups is new in Ignition 8, but the concept comes from scan classes in previous Ignition versions. Tag groups give you a place to define settings for how you should poll a device, such as poll mode and frequency. When you create tags in Ignition, you assign them to a tag group so they know how often to poll the PLC. Consider the ideal poll rate for your data points. Create additional tag groups as needed for slower or faster rates. Assign tags to a slower tag group for reduced network traffic. Assign tags to a faster tag group when needed. Avoid fast polling SQL query tags just to check if values have changed. Only query the database when needed. Poll rate for expression tag scripts should not be faster than the execution time for the expression. If you have a complex, long-running expression, other tags in the group could be delayed while the expression executes. If all tags are set to default tag group, one long-running expression tag could slow down all tags on the gateway. The next mistake is using the default historical configuration for all tags. By default, a tag with history enabled will record on change if the value changes by 1/100th. Now this gets a little more complicated in analog mode, but when thinking about capturing value changes, just start by considering the significant digits for your data points. A floating point tag may not be accurate to 2 decimal places, and the log can have many extra records with insignificant digits. Other floating point tags may have more significant digits, and value changes could be missed. In some cases, you may require values recorded at set intervals instead of logging every change. The solution here is tailoring your historical configuration. It's important to determine the best sample mode for your needs, on change, periodic, or by tag group. On change mode will record values only when the tag changes by the deadband amount. Periodic and tag group mode will record values at set intervals. You may choose to record a tag value every 5 minutes or only once per hour. Set deadbands to the appropriate number of significant digits for that tag to reduce unnecessary records in the database. You can also change your deadband mode to percentage rather than absolute mode. Next, we're going to talk about a little bit about architecture. Do you need a hub and spoke architecture? Does your system need a scaled out or enterprise structure? Will a standard setup be enough? Finding the best architecture for your project allows you to optimize the number of tags your system can handle. Standard architecture is valid for the majority of use cases, but the most common architecture mistake is overloading a single gateway. As your system grows, it can be tempting to try to over-leverage a gateway by adding more and more devices and tags. At a certain point, you'll see performance degradation on the gateway, such as stale tags, high memory and CPU usage, or clock drift log warnings. The solution: consider distributed architecture. Consider this before a system gets too big. Rather than overloading a single server, you can split the load between the front-end tasks and the back-end tasks. The back-end gateway handles back-end communications, dealing with all the PLC and device communications. The front-end gateway handles all of the clients, serving up data pulled from the back-end gateway. This is all made possible through the gateway network, connecting gateways to each other and allowing tags to be shared through remote tag providers. The right time to move to a scale-out architecture will be different for each system, but it's common to evaluate this architecture when you have about 250,000 tags.
Thank you, Mara. Before we move on, let's do a quick recap. The common data collection and logging mistakes that we covered are improper or inefficient polling frequencies, as well as poor tag structure and organization. Now, the solution for that is that you need to go in and set appropriate poll rates and tag groups. This means that if you are connecting up to a PLC and you just, say it's an Allen Bradley device and you see all the tags and you just drag them in, it'd be easy to leave them at the default, which is once every second, when that's not necessarily appropriate for all of your tags. And we had a couple questions come in around this where people said, well, isn't this determined by engineers and things like that? The tag rates, isn't that part of the PID revisions, all that kind of stuff? And the answer is, you'd think it would be, but so many people just drag in tags and let all the defaults apply there. And so really coming in and making sure you set those appropriate, and also by defining UDTs for that structure is really what kind of makes the difference here. So you can make UDTs in Ignition match the UDTs that you may already have existing inside your PLCs. So use those UDTs, use a consistent folder structure, and the naming conventions you can set in Ignition, and those may be, once again, different than the naming that you use in the PLC, because you can standardize it in Ignition by using aliases.